Okay, on example 10 here, the application, the projectile motion, you need to make sure you've read through this. If you haven't read through it, pause the video now, read through it real quick before we move on. All right, so after you read through it, you'll notice you have an equation here. R is equal to 1 over 16 v sub 0 squared sine of theta times cosine of theta. And make sure you know what your variables are. You know R is your horizontal distance in feet that the projectile will travel. And v sub 0 is your initial velocity, which they told us is 78 feet per second. So I'm going to go up to the top here and we'll work on my equation just a little bit. So they told me that R was equal to 1 over 16 v sub 0 squared sine of theta times cosine of theta. Well, we know that v sub 0 is 78. Now, I'm not actually going to work that piece out yet because it comes out to be an ugly decimal, so it's just shorter for me to write it this way. Now, so I'm going to focus on this. I'm trying to solve for my angle, looking at both of my questions, and so I need to be able to get that down. It'd be easier if it was one trig function. So I'm thinking about all the different things we've done, and I know there was one I saw back in the double angles that had sine of theta and cosine of theta together, except it had a 2 in front. So if I had this as 2 sine of theta, cosine of theta, I could do something else with it. And I can change that to a 2. Just remember, if you multiply by 2, you have to multiply by its inverse so that it disappears, which is 1/2. So I can keep this. This is the same. If I literally went through here and worked this out, the number piece, I would still get what I started with above there. All right, so I'm going to go ahead and I'm going to combine these two fractions here to shorten my formula some. And so I get the formula that R is equal to 1 over 32 times 78 squared. And then that's 2 sine of theta cosine of theta was my double angle formula of sine of 2 theta. So this is a formula that I'm going to use to help me in my problems. So I'm going to move to the next slide here. And it says, at what angle must a player kick the football so that it travels 188 feet? Well, that 188 feet is that horizontal distance. That's that R value. So remember, your equation was R is equal to 1 over 32 times 78 squared sine of 2 theta. So plug in the 188. And then I'm going to have to work out this part here now, no options. So 188 equals 190.125 times sine of 2 theta. So we want to get the trig function by itself. Now when I do this, that 188 over 190.125 gives me an ugly number. So what I can do is I can just say, well then, sine of 2 theta is equal to 188 over 190.125. It's no big deal that I've got a decimal and a fraction here because this is my work. It's not my answer. Now remember, we're after an angle, but right now we're actually after 2 theta. So we're going to use our inverse trig function, our inverse sine function in particular here, to solve for 2 theta, and then I'll solve from theta from there. So I know that 2 theta is equal to the inverse sine of my fraction. And so when we type this in our calculator, I'm going to be in degree mode because degrees makes more sense to us on this problem. So, and I find that the inverse sine of 188 over 190.125 is approximately 81.43. So then we divide by 2, and we find that theta is approximately 40.7 degrees. So there's the angle that I need so that the football will travel 188 feet. Now, what angle is a horizontal distance the football travels a maximum? Well, the horizontal distance, the maximum from the center on your unit circle is 1. So I need that trig function part. So I need to, when I get to that sine of 2 theta, the maximum distance then would be 1 for that. So then just do the same thing we just did. Or actually, in this one, you don't even have to use your calculator because you can use your unit circle. Because where is y, because sine is y, equal to 1 at 90 degrees. So we know that 2 theta equals 90 degrees, divided by 2, and we find that our theta is 45 degrees. So if he kicks it, excuse me, at a 45-degree angle, then the horizontal distance that football is going to travel will be a maximum.